Welcome back. We're writing Little Man Computer in C++, and it's been a little while since the last video in this series. And I think I'm going to make this the final video, if you will. I think we've taken this sufficiently far for our purposes, and then maybe I'll move on and do some different videos with some other interesting topics. But what I wanted to do in this video was just tidy up a few things that I'd noticed looking back on the previous videos, and also just kind of summarize how I feel about what's gone on here. So where are we? So one thing I did notice when playing with this earlier was if I build the program here, and it's not the fastest compilation in the world. Oh, hello. Something's gone awry. What's that all about? That's quite interesting, isn't it? So, has there been an update to the compiler in the interim? That would be really interesting, wouldn't it? I have updated the command line tools, and what appears to have happened is seems to be now a little bit more aggressive in its requirements here. So what's it saying? Destructor called on non-final standard in input stream that has virtual functions but no virtual destructor. So I think we need to stick a virtual destructor on our two abstract classes. Is that going to be the same here? In instantiation of function template specialization. So up a little bit. Yeah. So they appear to be the same errors in each case. So let us have a quick look and find where they're hiding. So standard output stream. Is it in the? So that'll be in main. LMC, if I can type. So here it seems to want a virtual destructor. That's a little interesting. Destructor called on non-final that has virtual functions but non-virtual destructor. So what does that look like if I... Is it just a simple case of actually putting a virtual destructor on here? Let's at least just put a destructor on here and see what that does. Input stream. I don't know how to do a destructor. Is it that? How odd is that? Can I just do that? Ooh, hello. That wasn't what I meant to type. Let's just do make here briefly while we're here and see if that's still an issue. That does not appear to have rectified the issue. Destructor called on non-final standard input stream. Okay. So is it sufficient? Let's completely ignore that as an attempt at solving this. Is it sufficient to say that Is that going to resolve the complaint? Well, it's got different complaints now, which is a good start. So what are we complaining about now? Oh, unknown type. Name final. Is that not how you do final? Final classes. Right. Now we're going to have to delve into things now. Final class C++. That does appear to be the correct thing. It specifies that the virtual function cannot be overridden in derived classes, and this class cannot be inherited from. Yes, that's exactly what I thought it was. Oh, you put it afterwards. Okay, that makes enough sense, doesn't it? Let's put it at the back here. And here. Interesting that it let that go in previous versions here. So now what is the complaint? So we now have a destructor called and of course the same problem in the tests. That makes sense, doesn't it? Oops. As I just jumped to something random here. Yep. I'm still recording. We don't want to be recording. Let's go to the tests, wherever they're hiding. Here, and look for our fakes. And the same here, and hopefully that will be sufficient. Yes, that wasn't exactly how I was expecting to start this video, but perhaps a little the code's now a tiny bit cleaner. Yep, good. So if I do make test, all of the tests pass still. That's very good. Would have been unfortunate if that wasn't the case. So that's nothing to do with the fix I intended. The things I intended to address here, but it's a start, isn't it? So so if we add that to our repository and then move on, mark input and output streams as final. That's good. Back on with the actual show. So the one thing I was intending on showing when I run make there is that if we run make clean, you'll notice that we haven't actually removed the final executable because we failed to add it to our clean section. So if we do that now, it will complain that some of those things aren't there, but that's not a problem. Let's just do the full loop. We can see that it had deleted LMC on its own. It's interesting that it's such a slow compilation. Maybe it was before and I've just forgotten. And in a moment it should arrive at the final destination. And it does. It's got all of these files. If I do make clean, then we can see that that has gone away. Good. Excellent. And now we're going to have to compile again when we do some things, which is a shame, but never mind. Okay, so one other thing that I noticed in the main program here is we put together this little spike of main, and we check the command line arguments. We pull in the input file, and then down here, as I'm sure many of you have been screaming at your screens, we failed to actually replace the hard-coded file name that we're using, which is not very helpful. So if we replace that and then make, we should hopefully be able to still run the program, and then I imagine we'll find out that my initialization of the or instantiation of the string was in some way incorrect. Hopefully not, but you never know. We'll see if this gets the job done. It certainly appears to. Let's drop out of that. So again, check that doesn't quite work. And if we run that, we get a number. Hurrah! Excellent. And just to make absolutely sure, let's put a second program in here. What does this do? This program will take a user input, square it, output the answer, and then repeat, entering 0. Will end the program. Note that input that results greater than 999 will cause an error. Of course it will, because we have a very limited amount of space. If I copy that, make sure I'm not doing anything silly there, and paste that in. Excellent. Hopefully that will just work straight out of the box. Like so, and oh, isn't that lovely? What's the biggest we can do? My maths isn't quite good enough. 33. No, oh, it doesn't, it cycles. Ah, did we end up deciding that it was just going to be modular? That's fine. And excellent. And then we can double check and go back. Sample 1 still works. It does. There we go. We have a couple of nice little sample programs that we can now play with. Very good. Yeah, can't type today. So there we go. So that's a rough spiked implementation of main. I'm not going to take this any further in terms of testing at the outer layer. One could imagine creating some sort of test script, shell script that piped standard in, checked standard out into the outer program, just to make sure this ran as expected. But I'm not going to do that here. One thing I did want to have a look at is a few of these definitions here had something a little suspect in. So, for example, here we're marking in the declaration of this add label method that this int value is const. Now, in this case, this const value is completely redundant, as it doesn't provide anything useful to the caller of this API. That const is purely an implementation detail inside add label, and has no business being in this header file for the world to see. So we can just delete it like so. One thing to note in these other cases where we have const values, these are const references, which is a different thing. Const reference is actually something that you need to know about from the outside of this from the outside as a call of the API. But when you're passing something by value, you do not need to know that that is going to be used in a const manner inside. We can nip down the other cases here, a lot of them in here. So you can see nearly all of the parameters here are passing things by value, so we have no care here that they're going to be used in a const context like so. And is this the final header? Assembler, computer, and little man. I don't see any other headers there. So if we have a look here, we can I can actually get rid of that as well, even though that's in a virtual function declaration, still has no bearing on the public caller. That is a const reference, as is that, as is that. So there we go. So now we can compile this, and it should still be completely fine. And it doesn't matter that there's this this asymmetry between the definition and declaration headers. The implementation is the only thing that cares about those particular parameters being const. And assuming this compiles okay, which it does, we can just double check. Let's do sample 2 again, because it's a little bit more interesting. There we go. That still works. So that's const parameters. Another thing we can do is just to help the compiler out a little bit, and also to help out more so the reader of the code, is we can mark methods as const as well. Where so we've done that already here in this instruction, for example, but that's all in one place here. But inside here, some of these methods are not going to modify the state of the class, and therefore the method itself can be marked as const, just to give a little hint to the reader that nothing is really going on here that's going to change state. So for example, add label, that's clearly going to modify this label map here, but address for, if we go and actually look in the assembler CPP, only reads the label collection, doesn't modify it in any way, so we can actually mark that as a const method. And the same, this does need to be symmetric, so you mark that the same in both. Oh hello, what have I done now? So error, no viable overload operation for type const map. Take a basic map, blah blah blah, for that label. Interesting. Why is that an issue? Would appear to access the map in that manner, the function might actually modify label in its usage. That's a bit weird if that is the case. Let's just double check we haven't broken anything else in the interim. I've clearly picked a very bad example there, where map, it would appear, requires, or is accessing a map for some reason is counted as a modification operation. A little weird. That is, it is very strange. Parse instruction, however, I don't think uses address for. Let's hope this is a slightly less embarrassing example. So I believe this doesn't modify any of the state of the program. In fact, this could actually be a static method on the class, as it doesn't even use any state. Let's just check this. This is gonna get the job done first, and then I might actually upgrade that to be a static. A static method. Just to all of this is about giving relevant information to readers of the code here. So by marking this as const, it's clearly indicating that no state of the class is changed. Oh, hello, it's gone right. That no state is changed, but we can also alternatively mark it as static, which indicates that no state is used. So we've got a function here, pretty much a pure function here, that doesn't access any state, let alone modify it. And I think we have to do that as well. Hopefully I've done the correct. Can only be static can only be specified inside the class definition. Have I done that wrong? So what happens if I take that away? Something strange going on here. Oh, we are going to have to resort to Dr. Google. Public static methods C++ and see what I've done wrong here. So yes, that's not the kind of member we're looking at here. Static functions. So yes, I thought we could do this. Or maybe that's interesting. Can we not have a segregation of declaration and definition here, or have I actually just typed something in wrong? So did I check that? Is that going to complain? What's that going up here? Is it one way or the other way? Oh, it's just that way. So it's only on the public side that I do that. I'm going to double check that if I try and access something there. So that seems to work rather confusingly. The question is, I shouldn't be able to do this. What's the type of labels? Yeah, that's correct, isn't it? So I shouldn't be able to do that if that static is correct. Yes, excellent. So that's so I mark the static here, but not in here. And is that the case here as well, that this doesn't use any state? It does use parse instruction, which is also static, so I should in theory be able to mark this as static as well, like so. I should mention the reason that I'm getting this a little bit wrong is that most of the time when I'm writing C++, I'm doing it in Visual Studio with ReSharper, and that just flags methods as able to be marked as const or static, and I just hit the refactor button and it does it all for me. And I've obviously not been paying enough attention to exactly where it's been putting the markers. So we know all of that lot is going to require not being const or static, so that's fine. So that's those ones. So that was the assembler. If I have a little look at computer, this might be more interesting from a perspective of being able to mark const things. Although I'm going to have a suspicion that this array of memory is it might suffer from the same issue, the same issues that plagued us with the map. But we'll have a look anyway. So let's have a look at the computer C++ here. So set accumulator obviously modifies state, all of these sorts of things. Subtract, store, load, sets accumulator. Actually, it's going to look like everything is going to modify state, isn't it, in this particular? Yep, because that's all we do with these things. That's fine. I can live with that. So there's nothing of interest going on in computer. What about little man? So we know about these things. And we have some state of a computer, input and output stream. We have run instruction, little man, load program, and run. All of that is going to be modifying the state of at least the computer. So that's nothing of interest there. An interesting little diversion. Anyway. So that's all I really wanted to look at in here. Let's just go back to the tests and check everything's all built. Nothing to be done. If I run the tests, all the tests pass, of which we have 77. That's not bad for such a tiny little program. So to summarize, we spent quite a while. We spent quite a while here playing with the little man computer, and we've gone through the process of gradually developing this step by step, writing a little test and implementing the bits of functionalities we've gone through. One thing that kind of plagued me throughout, I was at a feeling that we'd kind of dived into object orientation a little bit early. When we were writing the first few tests, we were immediately creating a computer class and then adding methods onto that, and it felt that we'd kind of jumped the gun a little bit, and we perhaps could have worked a little bit further on just with simple functions initially, and until we'd proven the need for some object orientation, which I'm sure would have come along in time, but it seemed we dived in a bit early there. And along those lines, it felt like I wasn't quite aggressive enough in the refactoring as we went along, and things got a bit messier than they could have done. And so that slowed us down a little bit in the middle, and we didn't quite get the progress, the pace of development as I'd have liked. Part of this was the learning curve of as we were going along, but I think we could have done a little bit better, and hopefully we'll do on the next occasion. And the other thing that the final thing I wanted to mention as we went along is it felt like we were just testing a little bit too low a level. If you actually look through at all of the things that are public in our classes, for example, if I go to the computer itself, that's perhaps not the best example. If I go to the assembler, is probably a good example. All of this lot, some of that certainly strikes me as an implementation detail that didn't need to be public, but ended up being because we were testing directly those particular functions. And I think if I were to repeat the exercise, I'd try and work a little bit higher level. When developing next time. Anyway, that's all I really wanted to say. It's been quite a long series, as it turns out. I'm not sure I intended it to be this long when I started out, but it's been very interesting. And hopefully, in the not too distant future, a new series will be started where we can look at something a bit different. But for those of you who have made it this far, thank you very much for following along, and I hope you found it entertaining and valuable to you. And goodbye for now.